So how's everybody doing on the project so far? Okay, so if you have any questions about the project, just let me know. And yeah, I can provide support. So the observations, there's different types of observations we can get, and then there's positives and negatives of each observation. Shebham, you can go ahead.
So what is the due date of the project?
So the project is due on, so it is due,
Because on the portal it shows March 31.
It's 21st, I think.
yeah, April 21st. Yeah, it's due on the day of the final exam. So
Okay.
so April 21st is the final exam, and project report due.
Professor, I have a doubt. Like, what would this final exam conclude of? Would there be multiple choice questions or something like we did in the last assignment, like calculating variance and everything?
Yeah, like a lot of like multiple choice questions. There might be some short answer questions, and then yeah, it'll be April 21st, and yeah, it'll be kind of like the test we had before. Yeah.
Okay, kind of the test we
Okay.
had before. It won't have like making bar graphs or like the last assignment thing, right?
No, it'll be mostly like you won't have to do
Quiz,
that.
MCQs.
It's hard to do that online.
Right.
Yes, so like don't
Okay.
worry. Don't worry, you won't have to do that on the
Okay,
exam.
and what would be the duration of the test? Would it be like 1 hour or more than 1 hour?
Yeah, more than 1 hour, yeah.
More
Like
than
it'd be
1 hour.
like 2 hours, yeah.
Okay.
And if you need more time, then I'll give you more time.
Okay,
Thank
sure.
you. Thank you so much.
Thank you. Thank you so much.
No problem. So preliminary research is kind of what they do at the beginning before doing any sort of primary, secondary research to figure out what the problem is. And then secondary research is more like analyzing the research, the primary research. And then primary research is kind of collecting data from like it's like a census or interviews or a questionnaire. So like interviews are open-ended questions, generally face-to-face, unstructured to gather broad information in order to better understand the topic. Structured to focus on gathering information in particular areas can be done on the phone. So like focus groups, phone surveys, etc. Observations. It's important. Interviews are good to observe, and then questionnaires are good to get data for a lot of people, because you can send it out through email or mail and get data for like tens of thousands of people. So yeah, observations are going into the fields and analyzing what you see. You can do interviews, questionnaires, you could do surveys. So 4 key dimensions of control are the observations conducted in an artificial, i.e. manipulated by the researcher, or in a natural setting. Participant is the observer, i.e. the researcher or member of the group that is observed or interacting with the subject studied. Structure, to what extent the observation is focused, predetermined, systematic, and quantitative in nature. Concealment, are the subjects studied aware that they are being studied by researchers. So uncontrolled are usually used because it's cheaper, and you don't have to keep it like you don't have to find, like you can do it anywhere uncontrolled. The problem with controlled is you got to spend money to make it controlled. So you got to find a way to keep a lot of things constant, in a controlled environment. Uncontrolled, you don't have to worry about any of that, so you can just collect data. So like that's kind of like uncontrolled would be like if you went into Walmart and did a survey, and then controlled would be like, yeah, so uncontrolled, go into Walmart to do the survey, and then like controlled, do it in a fixed environment. So, yeah. And then also, you have the choice of interacting with subject or not interacting. Yeah, like it depends on what you want. Yeah, so you could literally you could do it by not interacting with them or interacting. It's up to you, but there's different results because you could when you interact with them, you could potentially skew the data, which is a problem. But if you don't interact with them, you won't be skewing the data based on their actions. And it's important to know if the subject should be aware or not unaware of being investigated. So like you should figure out if it's going to skew the data or not. If it's not going to skew the data, then you can make them aware of you. But if it is going to skew the data, don't make them aware of you researching. Because what happens is so what happens is they know that you're watching them. They may change how they act, and the results would be different. This is a problem. And then so yeah, then the Hawthorne studies are were done to determine interpersonal behavior in a group setting, and this was done in a manufacturing plant. They determined illumination studies, relay assembly experiments, mica splitting test room, and bank wiring room experiments. So the hypothesis was that greater illumination would yield higher productivity. So they did a control group where they kept everything the same as before, and then experimental where they did put illumination to find what the impact of illumination is on productivity. So like the control in this case would be, so the control would have no illumination, and then the experimental would have illumination. Yeah. So then they found that both groups, control and experimental, had increased productivity, and productivity increased even when lighting was reduced. So here the problem was they knew the researchers were doing research, so that impacted their behavior, and they started to work harder, which made the study flawed because the people changed their behavior when they knew the researcher was there. So the researchers shouldn't have let the people know they were researching because the data was skewed. So pros and cons of observations. Advantages: direct and clear in seeing people act compared to intent and I and Q. Behavioral information without asking questions. Settings can vary to adapt to a multitude of situations. Observe individuals otherwise unable to answer questions. Observations are generally more reliable and freer from bias, common interviews. Disadvantages: time consuming, reactivity to being observed might slant the findings. Researcher might have an observation bias in the interpretation of the actions. Difficulties identifying reasons or behavior behind motivation behind behavior. Facial expressions or body language could be misinterpreted. So taking notes are important to recall the events and observations. Determine the fact observed and interpretation of why it happened. Don't use the person's name, use a pseudonym. Use exact quote when possible. Yeah, so there's a lot of so take notes and relevant background information. Then separate someone's own thoughts and observation assumptions from which one actually observes. Record the date, place, name of researcher on each set of notes. Great job, everybody on the game. Yeah, great job. Great competition. Great job, Shubham. That was awesome. Great job, Nick. Great job, everybody. So, lecture 10. Quantified data analysis. So yeah, for questionnaires, you'll get raw data through the questionnaire. And then you can use this raw data to format, like you can format it into an Excel sheet and then make charts basically. So you can take this data here and make charts, bar graphs, pie graphs, line graphs to figure out what the trend is. So you could take the exam marks and then show it in a line graph to show, it would be better as a bar graph. You could use a bar graph to show exam mark by age, exam mark by gender, exam mark by year in college, exam mark by IQ. So you could do that. You could compare it across all those factors. And yeah, like this data, we could do bar graphs on that and show the mode on the most frequently occurring mark, most frequently occurring age, and the median exam mark and the average exam mark. We can do that in Excel. So yeah, like this chart's a nominal social security number, gender. We could use a bar graph or pie chart. For ordinal, we can do like a satisfaction rating, which is median, semi, interquartile scale. And then yeah, we can use all those types of things. So here for plant growth without compost, we can use mode and median. Yeah. So the following data are the average weekly mortgage interest rates for a 6-year period. What is this table telling us, everybody? What would this table tell us here? So yeah, using data on a previous page, this would show the midpoint would be the median here, so 7. And then 7 would also be the mode because that would be the most frequently occurring one. And that'll probably be the median also. Usually when it's normally distributed like this, like if it looks like this, the mean equals median equals mode, normal distribution. That's usually the case for normal distribution. So this is what a normal distribution looks like for the most part. It's like, it looks similar to this. So the mean would equal the median would equal the mode. So yeah, here, this is normal distribution here. So the mean equals the median equals the mode, but with the negatively skewed distribution, the mean median mode would be all different, and then positively skewed, the mean median mode would be all different. And a histogram is a type of vertical bar that is used to depict the frequency distribution. And then the pie chart shows the percentage share for, let's say, for each company. So here, this would be the percentage of sales for each oil company. So ExxonMobil would have 42% of oil sales. Chevron would have 23% of oil sales. ConocoPhillips would have 19% of oil sales, and so on. So each percentage on this pie chart shows the percentage of oil sales for each company as a share of total oil sales. Yeah. So in that case, ExxonMobil sells about $270 billion a year in oil, while Chevron 147 billion, ConocoPhillips 121 billion. So this scatter plot is good for like economic growth. It wouldn't be good for like the grades for each person. This would be good for the amount of income and years of experience for people. So a line graph would work for that. And then this graph, the problem with this graph is that it's not a strong relationship. The dots are all spread out, so there isn't a positive correlation between life expectancy and birth and obesity rate. The lines have to be really close to the graph, like it have to be really close to the line in order for it to have a relationship. So like in this case, since the points are scattered everywhere, there is no positive or negative relationship between life expectancy at birth and obesity rate. So the correlation coefficient is how one parameter relates to another. And then correlation, not causation, not what leads to what. Higher the number, greater the length between the two. So here, there's a positive relationship between score percentiles and teachers' salaries in US dollars. Yeah. So the problem here is there's a positive relationship between drownings and ice cream sales. The problem here is there is ice cream sales don't cause drownings because they do not impact each other. E.g., like higher ice cream sales would not increase drownings because it doesn't make sense. They are totally unrelated. This is just a fluke. So you can see this a lot. So correlation doesn't mean causation. Like one can go up and the other goes up. However, one is not related to the other. Yeah, so that's basically it here. Causation, at times easy to see. You want to move an object, you push it, that is the causation. The direct relationship called the dependency as proven through a series of experiments. So yeah, that's important there, important distinction. So yeah, that's very important. So you could do this. What you could do here is you could do what you could do here is you could do a bar graph for this, and yeah, just show the frequency. This would be the mode here, because it has a 49 frequency. It's the highest mode, yeah. And then the percent, like, to find the mean, you would do 13 times, like 13 divided by 174 times 7.5%. Then you'd add 49 divided by 174 times 7.5% plus 44 divided by 174 times 25.3%. This other one here would be 28.1%. And then the next one would be 5 divided by 174 times 2.9%. So, and so on. So you would add everything so on. And then the median would be the midpoint between the percentages. So in this case, the midpoint would be, you would take like, you'd have to order these and then find the median, the midpoint. So 1.7, 2.9, 2.9, 2.9, 7.5, 9.2, 19.5, 28.1, 25.3. Reverse 25.3, then 28.1. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5. So 7.5 would be the midpoint, the median. So that's how you do it. And then you could take this data here and you could put it into, what you could do is you could do a bar graph. So employee number will be in the x-axis, and then annual salary will be the y. So x, y, and then you could do this on the y-axis too, to show, yeah, seniority by employee number. And then you could graph annual salary and its seniority on a line graph. So you can show what the relationship is between annual salary and seniority. So this is assignment 2 that we just did. So you converted it into median, mean, mode, and did standard deviation, all that stuff. So great job, everybody. Yeah, everybody did everybody did a great job on this one.